Hi there and welcome to tutorial 23 on problem solving with the normal. And this is for the Edexcel S1 A-level module, but is applicable to most other exam boards. And as always, if you're looking for further help with your studies, do check out youtube.com/Mr. Arnold's Maths. Excuse me. Okay, so this video we're going to look at how we can use the normal distribution to solve problems in context, and this is the final video of the course. So we've just got 3 examples to do. They're going to take a little bit of time, so we're not going to have any questions for you to try, but hopefully you'll get the idea from the 3 examples. Okay, here we go. So we're told that the performances in the 100-meter sprint of a group of decathletes are modelled by a normal distribution with mean 11.46 and standard deviation 0.32. The performances of these decathletes in the shot put are modelled by a normal distribution with mean 11.62 meters and standard deviation 0.73. And we're asked to find the probability that a randomly chosen athlete runs the 100 meters faster than 10.8 seconds. Okay, so I'm just going to start briefly by modeling the normal. So if I let x be the performances in the sprint, so x is normally distributed with a mean of 11.46 and a standard deviation of 0.32. So that will be 0.32 squared. And I want to work out the probability that a randomly chosen athlete runs the 100 meters faster than 10.8 seconds. So I want it to be less than 10.8. Okay, so just like we've been doing before, we're gonna use a little diagram to kind of get the idea of what's going on. So let's start over here. We know that the mean is 11.46, so I can put that in here, 11.46. And I'm looking for, or my raw score is 10.8, which is going to be down here somewhere, 10.8. And I'm looking for everything less than, I want the probability less than 10.8. Okay, so then what we do is we need to transform it to our regular normal, or the standard normal, which has a mean of 0, and we're going to look for a z-score, and then we're going to get a probability for that z-score because it will be the same. Now the only problem with this is that my z-score is to the left of 0 and I can't actually work those probabilities out. So I'm going to use the symmetry of the normal distribution to help me solve it. So I'm going to look actually over here, and that means that the score will be, or the z-score is negative. Okay, so I know that negative z in this case is going to be equal to the raw score, 10.8, minus the mean of 11.46 divided by the standard deviation, which is 0.32. So let's pop that into a calculator. So I'm going to do 10.8 minus 11.46, and then I'm going to divide that by 0.32. That gives me minus 2.0625. So that equals minus 2.0625. Let's just double check. 0.625. Excellent. Okay, now that's what z is, or that's what negative z is. So z must be equal to 2.0625. So what I'm going to do now is I'm going to actually look at my table and see if I can figure out what the probability of less than 2.0625 is. 2.0625. So let's go to the closest value. In this case, the closest value, 2.0625, so 2.06 will do. which is up here. 2.06 is 0.9803. So that is 0.9803. So if I'm looking for this area here, I can subtract this value from 1, and that will be equivalent to what we were looking for. So I'm going to do 1 minus 0.9803. So 1 minus 0.9803 gives me an answer of 0.0197. 0.0197, and this value here that we've worked out corresponds to this shaded region, and that shaded region has the same area as this shaded region here, so that means that the probability is 0.0197. Okay, let's move on to the next part of this question. So this time I'm asked to find the probability that a randomly chosen athlete puts the shot further than 12.8. So what we're trying to work out is I want the probability that I'm going to call my random variable, in this case y, that y is greater than 12.8. And let's just model the problem up here. So in this case, y is normally distributed with a mean of 11.62 and a standard deviation of 0.73. So 0.73 squared. And this is the probability we're looking for. So just like the last question, I'm going to use a few diagrams to get the idea of what's going on. Alright, excellent. So the mean in this case is 11.62. And our raw score is going to be 12.8. So 12.8 can go there. And I want the probability that it's greater than that. So I'm looking at this region here. And as always, we're going to transfer there or standardize it. So I'm going to look for a z-score. And I'm going to look for this probability here, or this area here. So let's work out our z-score to begin with. So z equals the raw score, or 12.8 in this case, minus the mean, which is 11.62, divided by the standard deviation, which is 0.73. So 12.8 minus 11.62, and then we're going to divide that by the standard deviation, 0.73, which is 1.6164. 1.6164, 0.6164. And well, normally when we're looking to the right of z, we look at the percentage points table. But if I look at my percentage points table, there's nothing here for 1.6164, so it's not particularly useful. So I'm actually going to look at the area to the left. I'm going to work out the probability that it's less than 1.6164. So the probability that z is less than 1.6164, we need to go to our table. 1.616, so that's closer to 1.62. I'm going to choose this value, it's the closest one to it, 0.9474. 9474, and that means to get my answer I need to do 1 take away 0.9474, because the green region is represented by that probability, the blue region is going to be found by subtracting it from 1. Right, so 1 minus 0.9474 is 0.0526. 0.0526. Okay, so that's part 2 taken care of. Let's move on to the next part. So it says here that assuming the performances in the two events are independent, find the probability that a randomly chosen athlete runs the 100-meter sprint faster than 10.8 seconds and puts the shot further than 12.8. So if I let, X is the 100-meter sprint and Y is the shot put. So essentially, what I want to know is what's the probability of X intersection Y, and because the two events are independent, that means it's the probability of X multiplied by the probability of Y. So go back to our first example, or the first part. So X being less than 10.8 is 0.0197. 0.0197, and we got to multiply that by the probability of Y being less than or greater than 12.8, which in this case was 0.0526. Let's crack out the calculator. 0.0197 multiplied by 0.0526 is 1. Let's actually convert this into just regular numbers. It's 1.03662 by 10 to the minus 3. Let's just write that down. 1.00. Okay, so now it says that assuming the performances in the two events are independent, find the probability that a randomly chosen student or randomly chosen athlete runs the 100 meters sprint faster than 10.8 and puts the shot further than 12.8. So this is going to involve the first two parts of this question. And remember, when two events are independent, the probability of X intersection Y, I'm using X and Y, is going to equal the probability of X multiplied by the probability of Y. And from the first part of the question, the probability that X is less than 10.8 is 0.0197. And the probability of Y in this question was 0.0526. So we're going to multiply these probabilities together. 0.0197 by 0.0526 gives me 0.001 to 3 sig figs. 0.001, and I could put the rest of it on there, 03622, but 3 sig figs, 001 404 in this case. And that's the 3 significant figures. Excellent. Okay, let's go on to the next question. So I'm told that cooking sauces are sold in jars containing a stated weight of 500 grams. The jars are filled by machine. The actual weight is normally distributed with a mean of 505 grams and a standard deviation of 10 grams. So X is going to be normally distributed with a mean of 505 and a standard deviation of 10. Find the probability that a jar contains less than the stated weight. So I want to know what's the probability that X is less than 500 grams. And very similar to the other example. So as always, we're going to use a little diagram to figure out what it is we need to do. The mean is 505. The raw score in this case is 500 grams, so it's to the left. That's 500. And we want the probability that it's less than that, so we're interested in this region here. And we're going to transfer that or standardize it so that the mean is going to be 0. We're going to look for a z-score here. Only problem is I can't find probabilities to the left of 0. So I'm actually going to need to use the symmetry, and I'm going to look at this region. So that will be minus z, and I'm going to look for that region. Okay, so let's get minus z. Minus z in this case will equal the raw score, 500, minus the mean, divided by the standard deviation, which is 10. And 500 take away 505 is minus 5. Minus 5 over 10 is minus a half. So minus z is minus a half. That means z will equal a half, or 0.5. So z is 0.5. So if I had another diagram, z would be 0.5. And can I find this region here using the percentage points table? Or maybe the regular table. Let's have a look. Can I find one for 0.5? A z-score of 0.5. Not in the percentage points table. So I'm going to have to look elsewhere. Right, I got 0.5 here, and that's 0.6915. 0.6915. So actually, this area, because I used the regular part, is 0.6915. If I want to get the blue area, or the blue region, I do 1 minus 0.6915. So let's take out the calculator here. 1 minus 0.6915 gives me 0.3085. 3085. That will have the same probability as that area here, which will have the same probability as that area here, which will have the same probability as that area here. So there's our answer. Okay, next part of the question. It says, in a box of 30 jars, find the expected number of jars containing less than the stated weight. Well, we already know that the probability that X is less than the stated weight, which is 500 grams, we already know that that is 0.3085. And if I want to work out the expected number of times something happens, it's the probability that it happens multiplied by the number of trials, or the number of times it happens. So this probability is 0.3085, and I'm going to multiply that by 30. So if I pick 30 jars, 0.3085 multiplied by 30 gives me 9.255. So 9.255. It's not quite 10, so approximately 9 jars. Okay, next part of the question. It says now that the mean weight is changed so that 1% of the jars contain less than the stated weight. The standard deviation stays the same. Find the new mean weight. So we're told that, well, I beg your pardon. We know that our random variable x is normally distributed. This time though we don't know the mean mu, but I do know the standard deviation is the same, and the standard deviation is 10. And I'm asked to work out the mean. I also know that the probability that x is less than 500 is equal to, well, 1%, which is 0.01. I got to work out the mean. So let's use a few diagrams here to give us an idea what's going on. I don't know what the mean is in this case. I do know that the probability that's less than 500 is 0.01%. So I know that this region here is 0.01. So we're going to transform it, as always, to the standard normal. So I'm going to look for a z-score. And I'm going to look at this region here. But I also know that I can't find probabilities to the left. So I'm going to use the symmetry of the normal distribution, get negative z, and look at that side, or I know that that side is 0.01. Okay, so I know that if I go to my percentage points table, 0.01 appears here, and that has a z-score of 2.3263. So minus z equals 2.3263, which means that z equals minus 2.3263. And we know the formula, z equals the mean minus, or beg your pardon, it's not the mean minus, it's the raw score. The raw score x minus the mean over the standard deviation is the z-score. So substituting in minus 2.3263 equals the raw score, which is 500, minus the mean mu over the standard deviation, which is 10. So I know that minus 23.263 equals 500 minus the mean. So I'm going to subtract 500 from both sides. So minus 23.263. Let's try that again. Minus, or negative 23.263 minus 500 gives me minus 523. So negative mu is minus 523, which means mu must be equal to 523. Fantastic. Okay, we're going to leave it at that now. So you should now be able to complete exercise 9E from the textbook. And well, yeah, that's it for this video and for the whole series. So good luck with the revision, best of luck with your exams in the future, and hopefully I'll be back again with some more videos soon. Take it easy.